Is extension of sine, cosine, and tangent values. Okay, so before we're talking about sine, cosine, and tangent values in right angle triangle, when there's a 90-degree angles, we think about the sine 30 degrees, sine 45 degrees, cosine, tangent of those values. So all the angles you're actually talking about is less than 90 degrees. Is that true? Okay, all the values talking about is less than 90 degrees. But actually sine and cosine and tangent functions, okay, it involved all the values. Okay, I can evaluate sine 320 degrees. Okay, I can evaluate sine 150 degrees. Okay, can you think about the obtuse angle, say sine 150 degrees, the obtuse angle can't be in a right angle triangle. Okay, can't be in a right angle triangle. So right angle triangle must all the angles will be less than 90 degrees. And also you have sine 90 degrees. Okay, you can evaluate sine 90 degrees, sine 270 degrees, okay, cosine 90 degrees. So all the values, okay, all the values you can talk about can be evaluated by using sine, cosine, and tangent. But how we can think about that? Okay, what we need to think about by we can't use triangles anymore because we can't create a right angle triangle, okay, and then still label 270 degrees. We can't do that. So we will introduce a new thing. It's called this unit circle. Okay, can you see a circle here in the Cartesian plane? Okay, we draw a unit circle in the Cartesian plane, center at 0, 0. Okay, what is the Cartesian plane? So x, y, x-axis, and cut into 4 x-axis, label center is 0, 0. Okay, what is unit circle? Unit circle is with radius of 1. Okay, with radius of 1. So we have a circle in the Cartesian plane. Okay, radius is 1. Okay, radius is 1. So what is the coordinates? Okay, what's the coordinates of this point? What do you think is the coordinates of that point? 1, 0. Okay, what's the coordinates of that point? 0, 1. Okay, and what's the coordinates for that point? Negative 1, 0. And how about this one? 0, 0. 0, negative 1. Okay, 0, negative 1. Okay, what's the length here? This length? 1. Okay, all the length from the center touch the circle is 1. Okay, it's a unit circle. We draw a unit circle here. Okay, tomorrow, have class tomorrow or maybe Friday. I will. Tomorrow's Friday. We won't have class. Do you have class? Yeah, we have. Okay, tomorrow I will show you a thing you can play on this by using unit circle. Okay, I don't have time to collect it today, but I'll just go through the theory today with you, and tomorrow you can have a look at that by using that model. So, okay, we introduce this unit circle in the Cartesian plane, and we use this unit circle to help us to find all the values for sine, cosine, and tangent of any angle. First of all, we need to know how to name the angle. Okay, the angle will count from which axis and go which direction. Okay, which angle is 30, which angle is 60. Okay, we're 0 degrees. So remember when you're talking about bearing, bearing will be start from the north, which will seem as the y x-axis, and go clockwise. Okay, so for Cartesian plane angles, that will count the angle in a totally different direction. We'll start from the positive x-axis. Okay, so we have, okay, that's x-axis, that's y-axis. Okay, I'll start here. Okay, let's say there's an arm. Start from x-axis. Let's make a angle with 0. And then I go anti-clockwise. I will make angle say 45 degrees. Go another circle, say it's 90 degrees. When I move to here, that's 180 degrees. Okay, moving further to here is 270 degrees. Okay, and also I can go negative direction. That's 0 degrees. Okay, go negative, that's negative 45. That's negative 90. So if you count that into anti-clockwise, that will be positive angles. If you go clockwise, that will be negative angles. So let's just do one example here. So we can draw a Cartesian plane, say y and x. Okay, when I have a line from the center and it's the same as the positive x-axis, I make a 0 degree angle here. I make a 0 degree angle here. if I go just cut that angle into half, I have make, okay, it's go this direction. Okay, from the x-axis, I'll go anti-clockwise, make a 45-degree angle here. Okay, if I go to this side, this arm go to the other side, this is actually making a 180-degree angle here. Okay, that's a 180-degree angle. And if the arm goes to negative direction, okay, if go negative direction, and we'll have, okay, let's go clockwise, we'll have negative 60 degrees. We will have negative circle, okay, we will have negative circles, negative angles, okay, if go negative direction, that will be negative angle. And so basically we can have all the angles, okay, not only within 360 degrees. If I go totally, okay, go from here for a full circle coming back, same position, I can say that's a 0-degree angle. I can also say that's a 360-degree angle. If I go another circle, I can say that's a 720-degree angle, okay? So I can represent, like, go how many rounds, and that's 360 times how many, okay? So if I say I want to sketch angle, okay, I want to sketch angle with let's say 600 degrees. Okay, I want to sketch a 600 degrees angle on this Cartesian plane. Where is it? Have a think about that. Where is it? If I want to sketch a 600-degree angle, where is it? I can go, that's 360 plus 140, right? 360 plus 140, that's 240. No, 5, 6, yeah, 240. Okay, so 360 is you go a full circle already. Okay, from here you turn around already, and then you keep going for 240 degrees. Okay, you keep going for 240 degrees. So you turn around already, going back to the original position, and go 240. Okay, here to here is 90. Here to here is 180. Okay, that's 270. Okay, it will be in between this quadrant. Okay, 180 is here. 270 is here. Okay, so it will be about here. 180 plus 60. Okay, 180 plus 60 give you 240. So this angle will be here. And this angle will be here. So here makes a 60-degree angle with the negative x-axis, but the actual angle we're talking about is already go 2 circles. I can say that's a 600-degree angle. Okay, so I can also say that's a 248-degree angle. Okay, so they're at exactly the same position. Okay, at the same position. Do you have your nose, girls? Yeah. Don't let me separate you, okay? Okay, so we talk about angles, and then let's come back to this unit circle. Why I say unit circle is help us to find sine, cosine, and tangent values. Okay, so first, let's have a look at this unit circle. Okay, let's just take off all these values first. Okay, so let's say we can make 45-degree angle. Okay, 45 degrees angle. So 45-degree angle, let's say is here. It's just this line. Okay, that's a 45-degree angle. Okay, from the center. Okay, so I make a 45-degree angle here. So that angle, let's say, is 45 degrees. Like in this unit circle, so we have 2 things in this Cartesian plane. One is this unit circle. Second is this angle line we draw. Okay, we have a circle, we have a linear. Okay, then we'll find 1 intersections. Okay, I won't go this direction. Okay, it's the ring. Okay, it's not a line, it's a ring. Stop here, go that direction. You only touch the circle once, right? There's an intersection point. Here is the intersection point. Okay, here is the intersection point. We'll have a coordinates, right? Think about, we draw a circle already, and I draw a particular line. There must be a point of intersection. Okay, a point of intersection. Like, I can't know exactly where is it. Okay, I can't know exactly where is it, but like the calculator may know, the computer may know, like there will definitely be a particular point that intersects. Okay, so let's write down the point of intersection. Because this is a special angle, I know what is the point of intersection. The point of the intersection of the 45-degree angle line and this unit circle will meet at √2/2 and √2/2. Okay, the point of intersection will be that. This is given to you. It's not asked you to find it. Okay, so I tell you I draw a 45-degree angle line and we meet with the unit circle at the point √2/2 and √2/2. Okay, so what's this coordinates represent? What's this coordinates represent? Like this coordinates will give you the sine and cosine value. Okay, will give you the sine and cosine value. What is the sine cosine value it will give you? Okay, it will give you the y value will be cosine 45 degrees. And the x value will give you cosine 45. And the y value will give you sine 45 degrees. Okay, it will give you sine 45 degrees. That's how this unit circle works. Okay, we draw a unit circle. Every point is the coordinates. And then a line will intersect with some point on the unit circle. And I'll tell you what's the point of intersection. The point of intersection just represents the sine and cosine value. Okay, it gives you the sine and cosine value. Just give you another example. Let's draw a 120-degree angle line. Okay, 120-degree angle line. So let's say the line will be here. The line will be here. So that's about 120. So from here to here, this angle gives me 120 degrees. And they got intersection here. Okay, with the circle, got intersection here. This point, I tell you this point of intersection is -1/2 and √3/2. Okay, I tell you this point will be -1/2 and √3/2. Okay, that's by calculator or by someone like who knows what is it, like give you this point. Okay, so this linear and the circle will have a point of intersection there. And that gives you the value. 1/2 will be -1/2 will be cosine 120 degrees. And √3/2 will be sine 120 degrees. So by looking at the coordinates, you know that sine 120 and cosine 120 degrees. So you can find any angle by using this method. You can draw any angle like with a line and intersects with the circle, and there will be a coordinates, okay, created a coordinates like a point of intersection, and you will find like it's given or like by calculator or something, they'll give you the angle line, okay, give you the coordinates. So both coordinates give you sine of that angle and cosine of that angle. So therefore, that's how you evaluate all the angles. Okay, that's how you evaluate all the angles. So the cosine theta is always represented by the x value, and the sine theta is always represented by the y value. Okay, so the first coordinate, first x value of the coordinates give you the cosine of that angle. The y value give you sine of that angle. That's how you create all the values, okay, for sine and cosine. Okay, so that's the very basic thing, unit circle. Okay, that's called unit circle. So doesn't matter which year level, year 10, year 11, year 12. If you start to learn trigonometry like sine, cosines, you always start from like a unit circle. Okay, year 9 you can't really learn unit circle that early, so we'll go through right angle triangle. So right angle triangle is only the first quadrant value. Okay, first quadrant value from 0 to 90 degrees. Okay, go anti-clockwise for 90 degrees. But actually, there will be all the values can be evaluated by sine, cosine, and tangent. Okay, so not only angle within 0 90 degrees have sine, cosine, tangent values. Any value have those any angle have those values. We will introduce the concept of unit circle, which I have introduced already. The unit circle is a circle of radius of 1 unit centered at 0, 0 of the Cartesian plane. The unit circle is used to define sine, cosine, and tangent for all the angles of the theater. Okay, so go from the positive x, go anti-clockwise, give you a positive value. Go negative clockwise, give you a negative value. Pxy is a point on the unit circle that is defined by angle theta. So you will sketch angle theta first, and there will be a point of intersection. So Pxy is the point of intersection there. Cosine theta is the x coordinate of the P, and sine is the y coordinate of the P. And what is tangent? Remember in year 10 we learned tangent equals to sine over cos, right? Sine over cos. So it's still true for any angle, okay? Still true for any angle. So tangent theta is always equals to sine theta over cosine theta, which is y value over x value, okay? Y value over x value. So let's have a look at this 120. Okay, let's have a look at this 120. So sine 120 is that, cosine 120 is that. Therefore, tangent 120. Tangent 120. So, okay, tangent 120 is root 3 over 2 divided by negative a half. Okay, the y value, which is the sine over cos, which gives you negative root 3. Okay, times negative 2 on both top and bottom, give you negative root 3. So it's the y value over the cosine value, sine over cosine. So it's y over x. That gives you the tangent value. That gives you the tangent value. Okay. And ASTC, okay, this is the very important thing. Okay, this is the very important thing. Let's draw another Cartesian plane, like unit circle here. Okay, I can't really draw a good circle, but let's say that's, for example, that's a unit circle. Okay, for example, if that's a unit circle. Okay, so let's see the angle in between 0 to 90 degrees, or say all the angle in the first quadrant will touch this. Okay, let's see the coordinates. Okay, the coordinates in the first quadrant. Okay, in the first quadrant will gives me, okay, positive and positive coordinates, right? So doesn't matter what angle you have in the first quadrant, you will touch the unit circle and the coordinates must be positive and positive. Is that correct? It's always positive. Okay, have a think about the coordinates in the second quadrant. What you can say about that? How about second quadrant, the coordinates? Okay, negative and positive. Okay, how about third quadrant? Yeah, negative and negative. Okay, it's both negative. The fourth quadrant, x first. Okay, positive. So positive and negative. Okay, so I have like, it doesn't matter what point is actually touching, it always have this property. Okay, in the first quadrant it's always positive, in the third quadrant it's always negative, in the second and fourth quadrant one is positive, one is negative. Okay, so x value represent cosine or sine? X coordinates represent. Have a look at this. You just have that on top. Cosine. Okay, cosine is the x value. So if your cosine is x value, so let's say, and y is sine value. Okay, and what is tangent? Tangent is sine over cosine, right? Sine over cosine. Okay, let's have a think in the first quadrant. Okay, let's think about in the first quadrant. x is positive, y is positive. Tangent is positive or negative? Positive, because it's sine over cosine. Okay, it's y value over x value is still positive. So we will write a letter A in this quadrant, which represent all the value is positive in this quadrant for both sine, cosine, and tangent. Okay, for both sine, cosine, and tangent. Okay, let's think about in the second quadrant. Cosine is positive or negative? Sine is positive or negative? Positive. How about tangent? Negative. So only one thing is positive. What is that? Sine. We have S here. Okay, represent that only sine in this quadrant is positive. Okay, only sine in this quadrant is positive. Okay, in the third quadrant, what you can say about the values? Okay, because negative or negative is positive. So sine and cosine are both negative. So we write T here. Represent only tangent is positive. Okay, only tangent is positive. Okay, what do you guys say about the last quadrant? Okay, cosine is x value, which is positive. Y is sine value, which is negative. Sine over cosine will be negative. So only cosine is positive in this quadrant. We have the letter C here to represent only cosine positive here. Okay, so this is very important. Okay, this is actually very important. We'll use this fact later. Okay, we'll use this fact later. But what you can see is, I can say it's a cast. Okay, from the fourth quadrant, CAST, if you remember that, just cast. You need to remember that. That is very important. Like CAST, okay, this thing, you need to remember. And remember the meaning of it. Okay, what means by C, what means by A. So C is only cosine positive, S is only sine positive, tangent is only tangent positive in the third quadrant, and all the values will be positive in the first quadrant. Okay. There's a question to say, where I should write it. Let's write that here. Okay, so explain that theta in between 180 and 270 degrees will give negative tangent value, no, positive tangent value. Like explain that if theta is in between 180 and 270 degrees, explain why the tangent theta will be positive. Okay, explain why the tangent theta will be positive. Okay, you can't say that because of CAST and in the third quadrant, so it's positive. You can't say that. Okay, you need to explain why tangent is positive in the third quadrant. Okay, so you say first, if theta is in between that, then the angle is in the third quadrant. It's in the third quadrant. The coordinates in the third quadrant will have negative x and y value. Okay, if theta is in between 180 and 270, then the angle is in the third quadrant. The coordinates in the third quadrant will have negative x and y values. So both cosine and sine value will be negative. tangent equals to sine divided by cos. Okay, so tangent equals to sine divided by cos, and which equals to negative values over negative values. So tangent will be positive. Okay, so tangent will be positive. So that's one of the exam question. Okay, that's one of the exam question I saw before 2 years ago. Okay, so explain why the angle there is positive. So you need to say first, where is the angle? Second, in that quadrant, is whether it's positive or negative. Okay, and number 3 is what is tangent? Tangent sine over cos. So if 180 theta is in between 180 and 270, then the angle is in the third quadrant. The coordinates in the third quadrant will have negative x and y values. Therefore, both sine and cosine value will be negative. Tangent equals to sine over cosine, which is negative values over negative values. Therefore, tangent will be positive. Okay, that's the whole thing we need to say. When you finish this, have a look at the question, like the tables below. Okay, have a look at the tables below. So tangent equals to sine over cosine. Sine over cosine, which equals to negative over negative. Okay, and then the next thing we talk about is special angles. Okay, what are special angles? There are 2 types of special angles. Okay, group 1 special angles. Okay, there are two kinds of special angles. So first group will be the angles lies on the axis and y-axis. Okay, for example, 0 degree, 90 degree, 180 degree, 270, 360, or negative 90, negative 180. Okay, so it's a multiple of 90 degrees. Okay, which is multiple of 90 degrees. Okay, so why those angles are easy to calculate? Why those angles are easy to calculate? Well, I actually should really give a larger space. Well, I'll do it here. Okay. So let's say where is 0 degrees? Let's say we have this unit circle. So we have this unit circle. Okay, well, we're just trying to sketch a unit circle. Okay, something like that. And I want to sketch 0 degrees. Okay, where is 0 degrees? 0 degrees is from the center. You sketch a line which the same as x-axis. Okay, this green line. This green line. Where they intersect with the unit circle? One, like what's the coordinates there? 1, 0. Okay, the green line and the unit circle intersects at the point 1, 0. Okay, the angle 0. The angle 0 intersects with the unit circle at 1, 0. So what's cosine value represent by x or y? Cosine value represent by x or y? X. So cosine 0 degrees will be 1 and sine 0 degrees will be 0. And what is tangent 0 degrees? Yeah, 0 divided by 1, which is 0. So you have sine 0 equals to 0, cosine 0 equals to 1, and tangent 0 equals to 0. That's how you find the values on the x-axis. So let's back to this table here. You will have sine is 0, cosine 0 is 1, and tangent give you 0. Okay. Next one, I'll sketch 90 degrees. I'll use a purple one to sketch 90 degrees. So 90 degrees is just on the y-axis. Okay, that's the angle make with 90 degrees. That's the angle make with 90 degrees. Where is the point of intersection? 0, 1. Okay, point of intersection is that point, which is 0, 1. Okay, 0 is the cosine value. So cosine 90 degrees will give you 0. Sine 90 degrees will give you 1. Okay, what is tangent 90 degrees? Okay, so it's sine over cosine, right? Sine is 1. Cosine is 0. So what's that? Undefined. Okay, which is undefined. So we have sine 90, which is 1, cosine 90 is 0, and tangent 90 is undefined. Cosine 90 is tangent 90 is undefined. Okay, 180. Okay, 180 is a line here. This angle will give you 180 degrees. This angle will give you 180 degrees. Okay, the arm go from here to here. So that is 180 degrees. So 180 degrees will intersect with which point? Okay, -1, 0 here. So cosine 180 degrees will equals to -1, which is the cosine value. And sine 180 degrees, which will be 0. Okay. Tangent 180 degrees will be what's tangent 180 degrees? What will be that? Tangent 180? 0. Okay. Sine over cosine, 0 over -1 will still give you 0. Okay, still gives you 0. So sine 180 is 0, cosine 180 is -1, tangent of that, which is 0. Have a guess of 270. What do you think you have? -1. Yeah, -1, 0, and undefined. Okay, so we can still have look on this. So we have a red one. Let's say we have 270 degrees. Okay, here is 270 degrees. Okay, from here to here, that's 270. Intersects with the point here, 0, -1. Okay, intersects with the point here, 0 and -1. So cosine 270 will be 0. Sine 270 will be -1. Tangent 270 will be sine over cosine, which is -1 over 0, which will be undefined. Okay, so we'll have -1, 0, and undefined. Okay, how about -90 degrees? What do you think about -90 degrees? Okay, -90 will be the same as 270. They have the same position. Okay, if two angles have the same position on the Cartesian plane, all the sine, cosine, and tangent value will be exactly the same. Okay, 270 is from here to here. -90 just from here to here. They are at the same place. Therefore, all the sine, cosine, and tangent values will be exactly the same. Okay, that's the first group of angles, which is lie on the axis and y-axis. And the group 2 angles will be two special triangles. Okay, coming from two special triangles, which is 30, 45, and 60 degrees. Okay, sine, cosine, tangent value of 30, 45, and 60 degrees are special. Okay, are special. So why 45 is special? Let's say we have a right angle triangle here. Okay, we have a right angle triangle here with length 1 and 1. Isosceles right angle triangle. What's the hypotenuse you think will be? √2. Okay, so what's the size of this angle? Okay, 45 degrees. Okay, what sine 45 degrees equals to? So it's 1 over √2. That will be √2 over 2. Okay, rationalize the denominator. How about cosine 45 degrees? Okay, 1 over √2 again, which is √2 over 2. How about tangent 45 degrees? 1 over 1. Okay, which is 1. Okay, you may ask me, okay, why you say this length is 1? Why it's not 2? Doesn't matter. Even though it's 2, the ratio will be the same. So for any sine 45 degrees in any right angle triangle will be the same. Okay? It doesn't matter if it's a small triangle or a large triangle. They always give you the same values. Okay? Give you the same values. So I can write down for 45 degrees. Sine of that is √2 over 2. Cosine of that is √2 over 2. And tangent of that is 1. Okay, the next triangle we have is equilateral triangle. Okay, have equilateral triangle. What's the angle in the angles? 060, right? 060. Okay, now if I sketch a vertical line from the top, like this. What's this angle? What's the size of this angle? 30. And here will be 60. Okay, if I say we have a side length of 2, okay, the hypotenuse is 2. What's the size for here? What's the length here? 1? Half of that. What's the height? What's the height? Just look at half of that. Just don't worry about that. Just look at half of that. That's a right angle triangle. You know hypotenuse, you know one side length. What's the other side length? √3. Okay. Square root of 2 square minus 1 square, which gives you √3, which is √3 for that one. Let's say A, B, and C. Okay, just look at the triangle ABC. Just look at the triangle ABC. What is sine 30 degrees equals to? 1 over 2. Okay, 30 is here, which is 1 over 2. What is cosine 30 equals to? Cosine 30? √3 over 2. Okay, cosine here over here. Tangent 30? What's tangent 30? 1 over √3. I would say that's √3 over 3. √3 over 3. So I'll write those values in. Sine 30 is 1 on 2. Cosine 30 is √3 over 2. Tangent 30 is √3 over 3. Okay. And similarly, we can find 60 degrees. Okay, we can find 60 degrees. So for 60 degrees, what's sine 60? √3 over 2. Okay, opposite over hypotenuse. √3 over 2. How about cosine 60? 1 on 2. And tangent 60? √3 over 1, which is √3. So I'll just use this triangle, can find all the sine, cosine, tangent of 30 and 60 degrees by using one right angle triangle. So I'll have √3 over 2, 1 over 2, and √3. Then I have 3 set of values. Okay, 3 set of values. Okay, that's the special angle. So we have 2 groups of special angles. One is all the angle with multiple of 90 degrees. 0, 90, 180, 270, 360, like you have 540, something like that. And the other group is 30, 45, and 60 degrees, which is we working out by this method. Okay, working out by this method. Okay, something you need to know is you need to memorize this table. Okay, you need to memorize this table. When I say what is sine 45 degrees, you need to be able to tell me that's root 2 over 2. Okay, that's root 2 over 2. Okay. So 12 values. No, actually it's 9 values and plus the method of finding multiples of that. Okay, you don't need to memorize the top line. You just need to know how to work it out by looking at the unit circles. Okay, so that's everything we learned today. Okay, that's everything we learned today. We actually just introduced what is unit circle and how to define sine and cosine values by using unit circle. And then we work out 2 groups of special angles. Okay, that's the first page. Okay, it's all the basics.